Understanding how Earth's freshwater is accumulating and perhaps more critically disappearing is of paramount importance. A new study in Nature this week has looked at changes in Earth's freshwater across the entire planet. To learn more, I spoke with Dr. Matthew Rodell from the NASA Goddard Space Flight Center in Greenbelt, Maryland.
So I'm Dr. Matthew Rodell, and I am chief of the Hydrological Sciences Laboratory at NASA Goddard Space Flight Center.
Could you tell me what your paper is about?
Yeah, so we use data from the German and NASA GRACE satellites to look at how water on the land has been changing over the past 14 years. And so this is the freshwater storage on and in the land surface. It includes groundwater, soil moisture, surface waters, snow, and ice. And what we saw were regions where water storage had been on average increasing during the period or decreasing. We found 8 were associated with climate change, 14 associated with direct human impacts, water management in particular, and groundwater pumping. And only 12 of them were caused by natural variability alone, which is not to say that natural variability wasn't part of the other ones, but only 12 of the 34 were only caused by natural variability, which shows that the human impact on the water cycle is powerful and visible from space.
What's the importance of this research? What can it do? What message are you hoping it gets out?
Well, we've seen maps of the world that show the nighttime lights, which indicate, where the human population is, and things like land cover change and temperature change. And this is the first time we have a satellite-based map of changes in freshwater availability. And of course, freshwater is crucial to life. We need it not only for drinking, but for growing food to feed a growing population. So it's important that we have an understanding of how freshwater availability is changing. So again, this is the first time we have this global map that's been annotated to explain, the causes of all the different changes in freshwater that we're seeing.
Okay. One thing that I found very interesting on the paper was your use of trends and how they would be endure into the future. And I was wondering, how confident are you in these enduring trends?
Well, some of them, when I say that 12 of the trends are related to natural variability, we expect those to fade over time. The trends that were associated with human activities like groundwater pumping, people are somewhat addicted to groundwater use for irrigating agriculture. So it would take a substantial change, perhaps a policy change or a great improvement in water use efficiency in order for those trends to diminish. On the other hand, these aquifers could start to run dry, and then things would come crashing down in terms of agriculture. Regarding the climate change impacts, where we see, some of the biggest ones are where we see the ice sheets and glaciers slipping into the ocean and melting, and those we expect to continue as long as global warming, unless we suddenly went back, cooled off 1 or 2 degrees. With only 14 years of data, we can't say with confidence that it really is a climate change impact. It's just something that is interesting and bears watching in case it turns out to be a climate change impact. The GRACE follow-on mission is scheduled to launch within the week, we hope, and that's going to continue to extend this important record of terrestrial water storage observation.
Do you have any specific experiments or data you want to get from this new mission?
Well, the most important thing is the continuity of the measurement. So we need to continue to follow the situation around the world and see where groundwater continues to be depleted, and also look at these potential climate change impacts. If we get 15 years of data out of GRACE follow-on, that would be great, and it would give us a lot more confidence in our conclusions about the climate change impacts.
If in a couple of sentences there was one thing you wanted the public to take from this, what would it be?
Well, water is crucial to our existence, and we need it for growing food around the world. That's the biggest use of water around the world, is for irrigating agriculture. And so it's critical that we have an understanding of how freshwater availability is changing. And this is the first time we really have a global map of how those changes have been occurring over the past 15 years.